Okay, here we are for the Algebra Unit 9 test review. All right, the topics here on the test are listed. You also receive that worksheet tomorrow in class, and you'll be able to have the opportunity to complete that. So let's get started here right away. These are the topics of the test: one variable inequalities, system of two inequalities, zero product property, exponential growth decay, domain range, and sequences. We'll do these in this order. First, we'll do one variable inequalities. The instructions will be to solve the following inequality, represent your solution on a number line. Solving inequality is just like solving an equation, okay? So we're trying to get the x's on the same side and isolate them at the same time. So first step here will be distributive property. So we'll have 6 minus 2x greater than 8 plus x. All right, and then at that moment in time, you want to get all your x's on one side and all your variables on the other. It doesn't matter which order you do that in. Okay, but one suggestion might be to take this negative 2x and add it to the other side, plus 2x, plus 2x. So we'll end up with 6 greater than 8 plus 3x. And then I'm going to subtract my 8 from both sides. Okay, so I end up with negative 2 greater than 3x. Divide by 3. So I end up with negative 2/3 greater than x. Now that's hard to graph. Typically what I say is have your variable on the left side. So if we're going to flip the variable, we just have to flip everything in the statement. So x goes to the left, the symbol flips, okay, and then the negative 2/3. It says represent your solution on a number line. All right, so we're trying to graph x is less than negative 2/3. So I want to put a couple places on this number line here. You don't have to get too crazy. And I think the ones on the test are whole numbers. But we plot the point at negative 2/3, okay, which will be approximately, here is an open circle, because this is not an equal to. So open circle. And then x is less than that, so less than is to the left. So we would shade to the left and draw an arrow at the end of it to say that all the solutions starting at negative 2/3, just after negative 2/3, but not equal to, all right, and left or less than are going to make that statement true. Moving on to systems of two inequalities. So graph the system of inequalities, shade your final solution region. So here we get a little practice at graphing. I'll do the parabola, all right, in the blue print. I'm actually going to, you can use your graphing calculator to graph this, or you could use graphing shortcuts. I'm going to switch this to graphing form, all right, by dividing the middle number by 2. So I get x plus 1 squared. 1 squared is 1, but I want negative 8, so I have to subtract 9 to get that. So that's going to tell me left 1, down 9, over 1, up 1, over 2, up 4, over 3, up 9, okay. So let's see here, this will be here, and this one will be here. Okay, and it's just a less than symbol. That means I'm going to have a dash line here when I graph this, because points on the line do not count. Okay, now I'm going to do the linear portion here in red. We use graphing shortcuts again. This is the starting value, and this is the slope, or the growth. So I'm going to start at negative 5, and I'm going to go up 2 over 1, up 2 over 1, so forth, down to left 1, down to left 1. Okay? And then I'm going to use a dash line again to represent, because I do not have an equal to symbol. And now I need to shade. So the shading is the hard part. And what I'm looking at here is the y statement. So for the line, it says y is greater than. So what's greater than this red line? Above or below? What's greater? Above is greater. So I'm going to shade on this side of the red line. Okay, above it. Okay, but for the blue line, it says y is less than. So if I look at the blue line, I'm shading below it. All right. And then my final solution region is going to be where both are true. Okay, so I want where I'm above the red line but below the blue line, which will be here. All right, here is no good. It's above the red line, but not below the blue line. Here is no good because neither of them are true. This is no good because only the blue is true, not the red. And then this one here is okay because they're both true. They're pointing at each other. All right. Zero product property. For zero product property, we want to factor first. Now you look at this statement here and you don't see a squared, you see a cubed. So we got to look at this and see that we have an x, an x, and an x. And realize that before we even begin the process, we need to factor an x out of everything. So if I do that, if I take an x away from each of these terms, I'll have 3x squared, 13x, minus 10. Now I can do my zero product property. So I'll fill in my box and diamond. Okay. And then I'm going to multiply to get the top of my diamond, negative 30x squared. And I'm going to ask myself that question, what do I need to multiply to get negative 30? So when I add, I get positive 13. The answer there is going to be positive 15 and negative 2. So I fill those into my box. And then I want to get the outsides of my box. So 3x squared is going to be 3x and x. I put the 3x here because of the 15, because 3x times 5 is 15. And then x times negative 2 is 2x. So I have my two factors, and I don't forget about this x that I had at the beginning. So I let them equal 0. So 0 equals x, x plus 5, and 3x minus 2. Let each of them equal 0. So x equals 0, x plus 5 equals 0, and 3x minus 2 equals 0. And then solve. Well, x equals 0 is already solved. X plus 5 equals 0. X will be negative 5. And if I add 2, divide by 3, I'll get x equal to 2/3. And these represent my x-intercepts. Okay, so there would be 3 of them there. Exponential growth and decay. So Bailey has a truck that was worth $45,000 when he bought it in 2010. The truck is now worth $9,622. Write an equation in y equals a times b to the x to represent the value of the truck since 2010. There's a couple ways to go about this. Some of you I know will probably use a calculator. So if this is year 0 and now is 2014, okay, which will be year 4. So if I look at a table, okay, I would have year 0 as 45,000. I don't know years 1, 2, and 3, but year 4 would be 9,622. And I know some of you know how to do this on the calculator using the stat, okay, and xreg, because this is exponential. All right, because when we write this equation here, we have y equals a times b to the x. A is the initial value, which is 45,000. We do not know the b value, so the x. All right, but we do have enough information to find it algebraically, so that's the method I'm going to show here. So I would plug in a y value, 9622 equals 45,000. Okay, and I want to make sure I get all this recorded here because I'm going to get off the screen. So start over here. So 9622 is the y value, equals 45,000, initial value, b to the 4th. So the first thing that I'll do is divide by 45,000. And again, you don't have to do it this way. You can use the calculator to generate the equation if you'd like. All right, so let me get my calculator here. Okay, so I have 9622 divided by 45,000, and I get 0.2138 equals b to the 4th. Don't round this number off too much. Then I want to take the 4th root, so I'm going to push the math button, x root of my answer, and, whoops, 4 as x root of my answer, and I'm going to get b to be 0.165. Okay, so when I write my equation, then I have all my pieces now, so I can write the equation y equals 45,000, okay, times 0.165 to the x. Okay, and by what percent, so b value, did the truck depreciate each year? Well, if the multiplier is 0.165, we would want to figure out what 1 minus that is, because it's depreciating, to get the percentage that it's depreciating by. So 1 minus 0.165 is 83.5%. Okay, so it's decreasing by 83.5% per year. No, it doesn't seem to work. All right, figured out where I goofed up here. Just made a mistake here in this calculation. This b value actually comes out to be 0.68. So sorry about that, which means my equation is 0.68. Again, sorry about that. Must have hit the wrong button on the calculator. Oops. Okay, 0.68. Which changes this a little bit. All the process here was the same, just somehow push the wrong button. So 1 minus 0.68 gives me 32% decrease. Okay, how much will it be worth in 4 more years? I take my original 45,000, 0.68, and instead of plugging in an x or a 4 here, I plug in 8, because 4 years ago and 4 more years. So 45,000 times 0.68 to the 8th, and I get 2057. Time to trade in. Domain and range. So state the domain and range of each function. The first one is a parabola here. Okay, so the domain for every parabola is always all real numbers. Of course, you could also write that as negative infinity to infinity. Okay. The range, you would have to find the vertex, okay, to get the range. All right, well, there's a quick way to find the vertex. You take the opposite of b over 2a, all right, or you change it to graphing form, which for this one will be pretty tough. So negative b, so that's negative 13 over 2 times 3. So that's negative 13 over 6. All right, and if I do that, I get, messy fraction. Okay, I get negative 2.167. So that's my x value. I got to plug this answer into the equation to get my y value. So I'll do 3 negative 2.167 squared plus 13 negative 2.167 minus 10. So 3 negative 2.167 squared plus 13 times negative 2.167 minus 10, and I get negative 24. So y is negative 24. So my range will go from negative 24, okay, is less than y, is less than infinity, less than or equal to that for y. Okay. Now for the absolute value here, again, domain for absolute values is always all real numbers. Doesn't matter what x value you plug in there, you're always going to get all real numbers. You're always going to get an answer. Now this absolute value is written in graphing form, so I can see the vertex here. My vertex is negative 2, 5. And this tells me that it goes down. So the y value of 5 is as high as it goes. So it's going to go from negative infinity to y equal to 5. Now, the best way for some of you to probably do this is to type these in to y equals on your calculator. Okay, and then you can use the table to find range. Okay, domains is always all real numbers for those. Last, sequences. So consider the sequence 54, 135. Okay, well that's not very much information. Dot, dot, dot tells us it continues. If the sequence is arithmetic, that means we're adding. Okay, determine whether 378 is a term. So what do you have to add to get from 54 to 135? Well, the only way to figure that out, or the easy way to figure that out, is to subtract. 135 minus 54, and you get 81. Okay. So 81 is our common difference. So then, is 378 a term? We have a couple options here. You can let 378 equal 81x plus 54 and solve this for x. So 378 minus 81 is going to be 297 equals 81x. Divide by 81 and we get, goof that up again. What am I doing? 378, sorry, minus 54. Come on, Mr. W. And I get 324 divided by 81, and I get 4. So because this number is a whole number and positive, that means that 378 is a term. Yes. Of course, the easier way to do that will be to take 54, 135, and just start adding 81 each time. Okay? You just keep adding 81. You get 216, 297, 378. Bingo. Okay? That's the easy way. Now, what if it's geometric? If it's geometric, we got to figure out what to multiply by. So 54 times what gives you 135. And the only way to figure that out is to divide. So 135 divided by 54, and I get 2.5 as my multiplier. So again, the easy way would be to keep multiplying by 2.5. So 135 times 2.5 is 337.5 times 2.5 is 843.75. So we completely skipped over 378. No, it is not a term. Keep in mind on tomorrow's test that this says show work. You cannot just write yes or no. You must show me either the algebraic steps or the steps of writing out the sequence to determine whether it's a solution or not. And good luck in your studies. I'll see you tomorrow.